8.3. So 8.3, the only real new idea here is the whole combining like terms. Okay, so 8.3 is operations with radicals, but what's actually new here is just more than one term. We already did the operations with single terms. Really all we're doing here is more than one term. And the big idea is you can combine like terms with radicals. So for example, number 2 is 9 root 5 plus 6 root 5. And what's that equal to? Exactly, 15 root 5. Whoa, I wrote it wrong. Okay, and so you could think of it like 9x plus 6x equals 15x. Or like, and this is what's actually happening, what's the GCF of this thing on top? What's the greatest common factor that comes out of both of those? There's a 3, and?
5.
You're close, not 5.
1.
Square root of 5. So, really what we can think of as a common factor, not the GCF, is root 5. So we could factor out the root 5, and we'd have 9 plus 6. And what's 9 plus 6? 15. So this is root 5 times 15, or 15 root 5. That's actually the reason we can combine like terms. I don't know if you guys have ever thought about it, but like why can we add 3x's plus 5x's? I mean, part of it's like I got 3 apples and 5 apples, so obviously I've got 8 apples. But another way to think about it is the GCF here is x, so you take out the x and you have 3 plus 5 left over. And so 3 plus 5 is 8. So 8x. So that's another way to think about adding like terms. Anyway, I always like thinking about simple things in way too complicated ways. It's a hobby of mine. Okay. 19 root 7 minus 2 root 7. What's that?
17.
Well, I said root 7, I wrote root 2. 17?
17 square root 7.
Yeah, there we go. Like terms, we can combine them. Okay? 8. What about 9 root x plus 2 root x? There we go. 11 root x. Okay? What about 8 root 3y minus root 3y?
7 root 3y.
Yeah, not the common mistake. What do you think the common mistake is? What do you think people accidentally?
Just put an 8 instead of subtract a 1.
Exactly. Not equal to 8, right? We're taking 8 of them and subtracting 1 of them. We're not canceling out the 3y with division and having just the 8 left over. Okay, another one, similar to that, 16, what's root 3 plus root 3?
Root 3?
Yeah, exactly. 2 root 3, and one last one.
So what if they're not common?
Ah, then you can't combine them at all. Yeah, we're gonna get to that in just one sec. So one more where you can combine them is what about 7 root 17 minus 10 root 17 plus 3 root 17? Well, we just combine these and we get negative 3 root 17 plus 3 root 17, or 0 root 17, or it's just 0.
Just multiply it.
Right? Because they just all cancel out. Yeah, you think about it like terms, you know, we have negative 3 of these plus 3 of these. Yeah, they cancel out.
So the negative on the 3 goes into
No, just the
Oh, this
coefficient.
is one full term.
Yeah, it's one full term. This is one term plus one term there. Yeah, okay. The big idea after this is to combine like terms. We must simplify every term completely first. Okay? So, do an example of this. I would do it below, but instead I'm gonna do it over here, just so everybody can see it. Here's 24. So root 3 plus root 27. Okay, right now, just to be clear, these are not like terms. Like x plus y or x plus x squared. We can't combine these yet. Okay, they have to have exactly the same square root if we want to combine them. So, what do we do first?
Since it's addition to combine like terms, we must first simplify
Simplify
every
the-
term first.
Simplify the 27, 3 and 9.
Exactly. And so what does it become?
Squared. Plus 9 squared. Or plus 9 root square rooted. Which is 3.
Yep.
3 square root 3.
There we go.
Yeah.
Exactly. Perfect. Okay, so now that you've simplified it, we can combine like terms. Now they are like terms. Right? And what's root 3 plus 3 root 3?
3 root 3. 4 root 3. 4 root 3.
4 there, because we have one of them plus 3 more, so we get 4. And that's the majority of the problems in this section are gonna look like that, or one other type of thing. So I'm gonna do 2 more examples like this, and then add one last idea. Alright, so here's 32. This brings up something you haven't seen before. What if there's already a coefficient in front when you start? Okay?
We would simplify it first,
Yeah.
and then bring out whatever, make the coefficient what it is, as long as the terms are like, then you can find whatever at the end,
Okay, so let's see, what would you write here?
9 and 3.
Okay, well, be more clear about what I would
Okay,
write.
so 5,
Yeah,
square root 9,
Yeah.
square root 3,
perfect. Minus,
3, square root 3, or square root 2, square root 9.
I would always write the perfect square first, but write numbers, yeah?
Yeah.
Perfect, and so what do we get in the next step?
So 5 times 3, square root 3, minus 3 times 3, square root 2.
Yeah, so,
So 5 times 15, square root 3,
perfect,
minus 9, square root 2.
perfect. And these are not like terms, so you can't go any further. And once you've simplified it completely, you know you can't go any further, you can check, does 2 go in 16, etc.? No. Okay. I don't know why I said 2, but just 4, 9, 16. Alright, one last one like that. What if we have, so Zach, I might have you help me with this one. Let's see, 36. What if we have square root of 6 plus square root of 9 plus square root of 24 plus square root of 25? What do we do?
Break down the square root of 24 and 25 and the smaller ones.
Right? So what do we get?
This is where I'm a little hazy, like, are you guys just, like, on 24 right there, so it's the square root of 27, so you just figure out 9 times 3 is 27, and then you just put the square root over the 9 and the 3? Is that what you guys are doing?
Yeah, exactly. So you write it in the product of two things where one's a perfect square. So we want to split this into something times something, where one's a perfect square. So,
8 and 3?
but neither 8 or 3 is a perfect square. So we're thinking we're looking for 4, 9, 16. Right, we're looking for those numbers.
So 4 times 6 is 24, and we're going with 4 because it's perfect square, right?
Perfect. So this stays a square root of 6 plus
3 times the square root of 3, right?
well, this one
There's just 3.
is just 3 because it's already a perfect square. Plus, and then what does this one become?
Square root, or 2 times square root of 2.
Or no, and the square root of 6 just stays because we can't simplify it, but the square root of 4 is the part that we can. And this was a product, so now we just replace the square root of 4 with the 2 times square root of 6. Okay, plus,
5.
yeah, and then,
Combine my terms. 3 square root 6 plus
Yeah.
8.
there we go. That's it. So first we simplify every term as best we can, and then we see what like terms we got that combine. Perfect. Okay, the one other type of problem we're having here is not anything new. We're doing the same problems we've done in past sections. We're just adding a square root to the mix. But I'll just add, to simplify, radical expressions with more than one term. One, I'll say, multiply everything out, aka distribute. 2, simplify each radical term completely, and then combine like terms. Okay, so we were just doing steps 2 and 3. All we're adding is what if now it's a product. Okay, an example right below that would be something like number 44, where it's square root of 5 times square root of 3 plus square root of 6. Okay, first we need to distribute. Yeah, so the first thing, anytime you're solving or simplifying, you've got these useless parentheses in there. You need to just multiply everything out. Okay, so if we distribute this in, square root of 5 times square root of 3 plus square root of 5 times square root of 6, we get square root of 15 plus square root of 30, and we're done. There's no perfect square that goes into either one of those. They're not like terms, so we can't combine them. I'll show you one more example, and then I'll just write a couple examples on the board for you guys to come do. But again, there's nothing new here other than something like 52, where now I have 7 plus root 2 times 8 plus root 2. You guys have all the abilities in that problem. I'm not adding any wrinkles. How would we multiply a binomial plus times a binomial? Yeah, right? 7 times both of them, root 2 times both of them, so we get 56 plus 7 root 2 plus root 2 times root 8. I'm just going to write it as 8 root 2 because I always write the number first, plus root 2 times root 2. Right, so first multiply it out, and then simplify every term.
I
Yeah.
have a question.
Yeah.
On the test, if you were to like accidentally write the number behind the root, would you take what's off?
Only if it's vague. Like if it's square root of 2 times 8, then yes. But no, if it's square root of 2 times 8, but no. So it just depends on how neat your writing is. But yeah, definitely, anytime something's ambiguous, I definitely take out points. And students will argue with me over that, and I'm like, yeah, I can't tell what you're answering, like, you know, if it's a true false, and you do the classic, like, TF, I'm like, yeah, no credit, or, yeah, no credit. So if it's ambiguous at all, I don't give credit. So this one you would simplify, you'd say, oh, that's square root of 4, or 2. And now I would just combine my like terms. 56 plus 2 is 58. 7 root 2 plus 8 root 2 is 15 root 2. So no new skills, all you're doing is combining a lot of past skills. Alright. Alright. I'm going to add 4 problems on the board, and I'm going to have you guys come and do them, and that'll be the end. So we got 48, here's root 6 times 7 plus root 6. 50 is root 6 times root 6 minus root 2. And 60, this is probably the hardest one, is root 6 plus root 3 times root 6 plus 5 root 3. And then the last one is 64. Alright, so come on up and do them. You don't even need to wait and do them at your desk. You just come up and do 4 problems, 4 last good examples. You can just toss that pen from there. That's
Pretty
fine.
hard shot,
I know. I touched the blue bin, I didn't make it.
That's the other ones.
No, those are all the good ones. No, those are
Oh,
the
good ones.
brand new ones. Come on, you guys. There's only 4 of you and 2 problems. Just can't be shy. Jeremy, you got one of them. You can't just quit on life. You gotta grab a hold of it, man. Live it. Otherwise, what's the point of being here? Shake it. Shake all the vigor we got. It's okay, you got that one. 60's awesome. Do 60. It's damn awesome. Yeah. Just a little negative mistake for you, but otherwise everything's so perfectly correct. I'll add an arithmetic mistake. 7 would be 23, but that's okay.
Oh,
So just be careful with that negative sign here. Yeah, nah.
yeah, because that's Jason Peterson.
Yeah, but then
Oh,
all of a
and then
sudden,
the square root of 39,
yes,
7, and
but then all of a sudden you have 2 negative signs.
well, that one follows it out, right? Because
Yeah.
it's 16.
But there's only one,
-7.
where's the negative term? There's only one minus sign. It's minus that term of root 7 times root 7.
So it stays just like the 7 is.
Yeah, that, cause look at,
So it won't become.
yeah. Yeah. Cause do you notice anything about the original thing that you're multiplying together? Look familiar at all? From last section in factoring, doesn't it look like a pattern? It's a difference of squares, right? So the first one squared, 16, minus the second one squared, 7. Yeah, it's a cool problem, I like that, and that's actually what you would use a lot in 8.4 when we rationalize it in I. Nice, well done, Louise. A lot of spectators here, good, that's okay, got 2 people grabbing off.
Wow, good advantage. So these 18s though, still take those down here.
So you have 2 options there, you could have combined the like terms first, or you could combine them later. Yeah, exactly.
No, so this just becomes 5 times 3?
Exactly, and that multiplication is key, a lot of people forget that, yeah. Yeah, and this is the type of problem you'll be seeing, like this is kind of the culmination of this section. So there'll definitely be a problem like that, for sure.
So I'm gonna combine these right now?
You gotta simplify it a little bit more. The reason you split that
Okay,
up,
so this would become 5 square root 2 times 3?
yeah. Although I would always write the perfect square first. You don't, it doesn't matter, but yeah.
Plus square, okay, so you're saying have the whole number in front?
Yeah. That way just, you never get confused with like your square roots are.
So it'd be 6 plus 5 times 3 times square root 2 plus 3 times square root 2
There you go.
plus 15. That's 6 plus 15 square root 2. Could have just done that all at once, but.
It's okay. Dan? There we go. There we go, that's it. Well done.
I don't think that many steps are required, but, you know, for me to.
Yeah, no, it's, you know, that's one of the best habits you can get into is showing every step and, yeah, I mean, the difference is, man, I mean, you're great on the test, showed it. Alright guys, so, that's where we'll end today, so it's perfect time, we got 3 bits left.